Alright, let's look at the homework 7.4, problem number 9. Alright, so I'm gonna make a substitution first. We're gonna let u be e to the 2x. Actually, sorry, it's gonna be e to the just x, right? So we have e to the x. Alright, so go through the usual drills. Du over dx is going to be e to the x, right? Then we know that here, take the reciprocal of both sides. So we have a dx over du, which is going to be 1 over e to the x. Then we can multiply through by du, right, to isolate dx. So it's a du over e to the x, right? So this is going to be equal to, right, you have an integral. Alright, so e to the 2x is just a square of e to the x. So it's going to be just a u squared on the bottom and plus 15u plus 54. And the numerator is 3 times u squared, right? And dx, I actually want to do one more step, but since e to the x is u, so I want to write it as a du over u. So we have a du over u. Right? So you can at least cancel square here with one of the u down here. Alright, then we're going to use find the partial fractions from here. So we have 3u over, right, so we have to factor this guy out. So you have u and u here. And we need to find two numbers whose sum is 15 and the product is 54. Would 6 and 9 would do? Plus 6 and plus 9, right? So it looks like sum of 6 and 9 is 15 and the product is 54. So I think this is going to work. Alright, so this is going to be equal to, alright, so as usual, this is just a distinct linear factors. We can just split it as a over u plus 6 and b over u minus 9 and put them back together. Right, so you have a u plus 6 times u plus 9. Right, then you have a, we multiply by u plus 9. And b, we multiply by u plus 6. Right, so let's compare the left hand side, the numerator there, and also the numerator on the right hand side. Alright, so we're going to just use a convenient value. So I'm going to try to eliminate b by using u is equal to negative 6. Right, so if you do that, negative 6 plus 9 is 3. So 3a is equal to 3u would be, so 3 times negative 6. So it's negative 18. Right, then you can just divide through by 3. To find a value. So a value is negative 6. Alright, b value, we're going to plug in negative 9. So u equals negative 9. And then, let's see, if you plug in negative 9, that's gone. So negative 9 plus 6 is negative 3. So you have a negative 3b is equal to, plug in negative 9, so negative 27. Right? So b value is going to be, so divide through by negative 3. So you're going to get the b equals 9. Alright, so we can rewrite this integral as, alright, so this is going to be equal to, right, integral. Alright, a is negative 6, so you have a minus 6 over u plus 6, and plus 9 over u plus 9, right? Then we want to do that with respect to u, right? Then we can easily find the antiderivative, which is, I'm going to pull out the negative 6. So you have a negative 6. Then you have a natural log of absolute value of u plus 6, and pull out the 9 from the second term. Then antiderivative natural log of absolute value of u plus 9, and then plus some constant c. Alright, then we're going to have to go back to the original expression. So you have a negative 6, natural log of u is e to the x plus 6 plus 9 times natural log of e to the x plus 9 and plus some constant c. Alright, so let's type this guy in. Alright, so we found was, let's see, negative 6 times natural log of absolute value, actually we don't need it, e to the x, and plus 6, right? And plus 9, natural log of e to the x plus 9. Because e to the x plus 9 is going to be always positive. E to the x plus 9 is always positive, so we don't really need the absolute value sign. Alright, so plus constant c. Alright, so let's submit for testing. Alright, it came back and looks like we got this one correctly. Alright, that's it. I hope that this was clear.